All right, our last section of Unit 4 should really be a review of exponential and log functions because we've graphed both of these before. We've also graphed natural log functions. So you should see an example of each of those on here. And then we're going to go into a little bit more detail. Identify domain and range, identify x and y intercepts. But let's just start with our exponential function form and log function form. So exponential function form, y equals a times b to the power of x minus h plus k. Log function form, y equals a times the log of x minus h with a base b plus k. All right, a couple important things to identify here. One really important piece, the k value. This is your horizontal asymptote. Which is at y equals k. Domain for an exponential function is always all real numbers, and then range is y is greater than or less than k, depending on if you're above or below. For log functions, h, this is your vertical asymptote. I might need to move that over. Vertical asymptote. It's at x equals h, and then now domain is either x is greater than or less than h, and range is always all real numbers for log functions. All right. So what I'd like to do here is graph both. Then we'll come down here and do an example where we graph state, domain, and range, and then identify x and y intercepts. All right. Remember, I like to just make a table for your parent function, which is just the y equals 3 over 2 to the power of x part, right? And then we'll take care of the negative 3 and plus 1 before we graph. The negative 3 in parentheses is a shift right 3. And the plus 1 is a shift up 1. The plus 1, that is your horizontal asymptote. And then 3, maybe 4 points is good for these graphs. I'm going to use negative 1, 0, 1, and 2. And we're plugging those in just for our parent function. So the negative 1 flips our base, we get 2/3. 0 gets us 1, 1 gets us 3 over 2, and 2 gets us 9 over 4. So negative 1 and 2/3, 0, 1, 1 and 3 over 2, 2 and 9 over 4, which is 2 and a quarter. 2 and a quarter right here. All right, so we have a graph that looks like this. Curving up, not as steep, because this is pretty close to 1, a base of 1.5. Let's state our domain and range. Domain, all real numbers. Range, everything greater than your horizontal asymptote of 1. All right, let's do the same for this log function. Our parent function is log of x with a base 3. We can take care of the plus 1 and minus 4 right now, our translations. The plus 1, that's your horizontal asymptote, vertical asymptote at x equals negative 1. And then the minus 4 is just a shift down 4. All right. Let's make a table here, plug in some values. Remember, for log functions and natural log functions, you always want to plug in 1 and the base, which is 3, and then hopefully you can remember from there just powers of the base. So 1/3 and 9. That's plenty of points. 3 to the power of 0 gets you 1. 3 to the power of 1 gets you 3. 3 squared gets you 9, and 3 to the power of negative 1 gets us 1/3, and then just multiply all of your outputs by 2 to get the opposite. So negative 2 positive 2, positive 4. Okay, let's go graph these points. 1/3, negative 2. Oops. You're graphing from your new origin, so right here. 1, 0, 3, 2, and 9, 4. All the way up here. And we have our graph that looks like this. Domain, everything greater than negative 1. Range is all real numbers because it's a log function. Okay, similar graphs, but slightly different. I want to graph one more here together. And I'd like us to, when we're done, not only identify domain and range, but also identify asymptotes. Okay, some of the times, but also identify intercepts. Some of the times you might be able to see your intercepts here. Like right here, we already have a x-intercept, which is at 1, 2, 3, 4, 5, 6, 7, 8, 8, 0. We also have a y-intercept that we already have graphed. 0, or 1, 2, 3, 4. 0, negative 4. Okay. There'll be times where you don't see your graph crossing the xy axis, and we're going to solve algebraically for those intercepts. So that's what I'd like to do on this first example. Let's go ahead and we'll graph this first exponential function together, and then identify our x and y intercepts. Okay, start with our parent function, 4 to the power of x, and then we'll graph our translations first. Left 1, up 5. Left 1, up 5. The up 5 is our asymptote, so y equals 5. And then we're going to plug in some values here. So let's use negative 1, 0, 1, and 2. 1/4, 1, 4, and, not 8, 16. And we're going to multiply all of these by negative 1/2. This is a reflection of the x-axis, and it's a vertical compression by a factor of 1/2. So we actually have an output at negative 1/8, negative 1/2, negative 2, and negative 8. Okay, so we can go graph these points here. Negative 1, negative 1/8. 0, negative 1/2. 1, negative 2. 2, negative 8. All right. Pretty steep graph because our growth factor, or our base is 4. This is not an exponential growth function. Our base is 4, which is a lot higher than 1, so it's going to be pretty steep. Our domain is all real numbers, and then our range is everything less than our horizontal asymptote at 5. But I'd like us to focus more on this part here, x and y intercepts. Okay, you can clearly see your y-intercept right here, right? That y-intercept, and it's from your original xy axis. So your y-intercept is at 0, 3, correct? Now, x-intercept is right here. We don't really know exactly what that point is. So to find our x-intercept, we're going to go ahead and just plug in 0. Remember, x-intercept is where y equals 0. So we're just going to solve algebraically. We're going to plug in 0 right here. 0 equals negative 1/2 times 4 to the power of x plus 1 plus 5. And we're going to solve algebraically. Move the 5 over. Times 4 to the power of x plus 1. Multiply both sides by negative 2, or just divide by negative 1/2, same thing. So we get 10 equals 4 to the power of x plus 1. We've solved these earlier. We would take the log of base 4 of both sides. And we have x plus 1 equals the log of 10, base 4. And then we're going to subtract 1 over, and we have our x-intercept. Punch that into your calculator. You would get an x-intercept at x-intercept at 0.661. So we'll just say let's just round to the nearest tenth. 0.7, comma 0. That looks like it's at 0.7, right in between 0 and 1. And you have your x and y intercepts, all right? Great, so there might be times where you have to solve algebraically for your x and y intercepts. Okay, I will identify all of those with you on these next two problems here. But why don't you go ahead and take some time. It takes 10, 15 minutes to graph a couple of these. So the video will pause. Try examples 2, 3, and 4 on your own. When you're done, domain and range, x and y intercepts, because those are going to be the questions I ask on the test. I'm not just going to ask you to graph these. I'm going to ask you to identify parts of the graph. All right, go ahead, 2, 3, and 4 on your own. State domain and range, x and y intercepts when you are done. All right, for number 2, negative log of x minus 3 to the base 2 plus 1. We had a couple points here. If we make our table and just use the log of x base 2, I would have plugged in 1, 2, 4, and 1/2. Vertical asymptote at x equals 3. We're shifted up 1. And then we're going to need to multiply all of the outputs by a negative and reflect it over the x-axis. So 2 to the power of 0 gets you 1, 1 gets you 2, 2, and negative 1. And then these actually all become the opposite. So positive 1, negative 1, and negative 2. Half and 1, 1, 0, 2, negative 1, 4, negative 2. Right. We have our graph. Okay. Couple things. You have an x-intercept right here. This x-intercept is at 5, 0. Y-intercept. We don't cross the y-axis at all because we are shifted to the right 3 units, so we don't have any. No y-intercepts. Domain, x is everything greater than 3, and range, all real numbers. Great job there. How about another log function? Log of x plus 2 with a base 1/3. Let's make our table. Left 2. Up 1. Would have plugged in 1, 1/3, 3, and 9. This would be 1, 0, negative 1, and negative 2. We don't have any vertical stretches or compressions, no reflections. We can just graph these points from our new xy axes. 1/3 and 1, 1, 0, 3, negative 1, and 9, negative 2. Okay, so our graph looks like this. X and y intercepts, you have both here. You had an x-intercept at, looks like it was exactly crossing at 1, 0. Great. Y-intercept, you probably had to solve algebraically for your y-intercept. Y-intercept is when you plug 0 in for x. So you were just taking the log of 2 with the base 1/3 plus 1. Just punch that into your calculator. You're going to get something like 0.36. So let's just round to 0.4. And that looks like we're crossing more or less here at 0.4. Domain, everything greater than negative 2, and range, all real numbers. Okay, for your last function here, this was an exponential growth function, an a value greater than 1, and the base is greater than 1 as well. Sorry, a positive a value, I meant to say. Let's apply our translations. This would be right 4. down 2. Move our table over here. I would just plug in -1, 0, 1, and 2. Gets us 1/3, 1, 3, and 9. And then don't forget you had a vertical stretch by a factor of 3/2. So we need to apply this to all of our y's. We get 3/6, or just a half. We get 3/2, 9/2, and 18/2, or sorry, 27/2, which is what, 13.5? Right. -1, positive half, 0 and 1.5, 2 and, or sorry, 1 and 4.5. And then 13.5 is way up there, so I'm just not gonna graph that point on there, but have our graph curving up to 2, 13.5. Domain would be all real numbers. Range is everything above your horizontal asymptote. And then you did have an x and a y-intercept. You needed to solve algebraically for both here. Okay, your x-intercept was at 4.3 if we round to the nearest 10th, and your y-intercept was at -1 let's round to the nearest 100th here, otherwise it would be 2, and we know we don't, cross at 2, so we'll round to the nearest 100th, -1.98. Barely, really close to your y equals -2, but we do not cross because that's our asymptote. All right, this is probably the most important part of this section, guys. Identifying x-intercepts, y-intercepts, domain, and range. You may have to solve algebraically for some, but those are the questions I'll be asking on the test, and I believe you have some on your homework. Go ahead and get started.